and neurological disabilities.
Good morning, everyone, and I wish to thank the organizing committee, both the local and the international, for inviting me to share with you some aspects of ethics and research. And the topic I was asked to talk about is stem cell research, which indeed is the cutting edge of science today. And if it will be successful, and hopefully it will be, it will probably change the way we know medicine in the next decade to a way that we don't know it at the moment. In order to understand the ethical dilemmas regarding stem cell research, I would like to give you a short overview on the facts concerning stem cells. As you can see on this slide, the concept, the idea, the understanding that stem cells are something that can be worked on is relatively new. There were two papers published in '98, one derived stem cells from embryos and one from blastocysts in an IVF clinic, and both are just a decade old, and already we have went through a very far way, both from a scientific, ethical, legal, and religious aspect. It is so imaginative that a group in South Korea has published in Science, which is certainly a very notable scientific journal, a fraudulent paper on deriving stem cells from therapeutic clonee, which was all fabricated, and it was a big fraud. I think those scientists are now in jail, but it only shows how the issue is becoming a very important one, and everyone is fighting from their point of view to go along. So what are stem cells? And I'm talking to people who may not know the subject from a scientific point of view. And I would like to stress two aspects of the multitude aspects of stem cells. One is that we're talking about pluripotential cells, and the second one, at the moment less important for our discussion, that it has an unlimited power of division. Pluripotential means that the cell is in such a primitive stage that it can go to any direction to create any tissue type that the embryo subsequently will have, or in fact we as people will have. We are composed of about 200 different cell types. We have hair and nail and heart and liver and brain and skin and so on, and each cell type is very different in the way it functions, in the way it looks histologically, and what the purposes of this particular cell is. And these stem cells have the potential, each of them, to differentiate in the future into one of the 200 or so cell types. Now, I'm sure everyone is aware of a different type of stem cell, let's say the stem cell in the bone marrow, which is a stem cell in a sense that it has a potential to differentiate to a mature cell of different types, but it is very limited to the types where it sits. So a stem cell in the hematopoietic system can differentiate it to either to a thrombocyte or a red blood cell or white blood cell, but this is a very limited power of differentiation. A more powerful way, which is still not very well known whether it is really functional or no, is the umbilical cord blood, which contains stem cells. And I'm sure you know that now there is a trend to preserve umbilical cord blood from born babies, so that if in the future this particular baby will suffer from leukemia and there will be no appropriate bone marrow donor, then we can go back to his umbilical cord blood and extract the stem cells from there and cure the leukemia and other blood diseases and so on. How functional it is, it's still a little bit debatable, but that is the concept of a stem cell. But what we are really talking about is this stem cell. We get a zygote, which is a combination of a sperm and an egg. It starts to divide, and at around 4 to 5 days, it becomes a blastocyst, which is a small ball of cells, probably barely visible by eye, like the dot at the end of the sentence, and it contains two types of cells. The outer layer are the cells that will develop to become a placenta, which will anchor the fetus to the womb, and an inner cell mass, which are about 30 to 50 cells, which are the stem cells, and each and every of these stem cells has the pluripotential power to develop into one of the 200 or so cells. Now, what is done in research is that the blastocyst is destroyed in a way that the outer layer is thrown away. We don't need the placental potential cells, and we harvest the stem cells, and we study what is the code that one cell becomes a skin, another cell becomes an heart, and a third cell becomes an eye. And once we'll master these codes, we will be able to use it in a way that will change the face of medicine, as I said initially. So this is how it looks under the microscope. The inner cell mass is here, that's just fluid, and the outer cell will become the placental cell. Now, where can we derive those stem cells? The most frequently used stem cells are from a pre-embryonic stage, from an IVF-derived blastocyst, the one that I showed you a minute ago, which occurs around 4 to 5 days after fertilization. There are also stem cells still available in the fetus, and we can either use a miscarried fetus or an aborted fetus. Some are in the amniotic fluid, and as we said, some are in the umbilical cord. We as adults still have some stem cells. The problem is to find them, to clean them. I just read recently that the primary teeth has a lot of stem cells, so if your kids are losing their milk teeth, gather them. It might be one day a good source of income. But there are here and there areas within us as adults where these stem cells can be located. Now, there are experimental sources. For instance, why destroy the blastocyst entirely, throw out the outer layer and gather the stem cells? Why not take a biopsy from the blastocyst, extract a few stem cells, work on them, and as I said earlier, they can divide in an unlimited fashion. We can get millions of cells from one of those cells and still keep alive, and we'll come to the term alive in a minute, the blastocyst. So far, it was not successful scientifically, but I don't see a reason why in the future we won't be able to do it that way. A more important way is to clone a blastocyst, and we'll come to it in a minute, what the difference is between this type of cloning and cloning of a human being or an animal. We can make a hybrid. We can take a cow's egg and introduce into it a human cell and get out of it the stem cells. Whether it will work or not, we don't know. So there are experimental ways to try to get those stem cells. Now, the cloning process is an important process because if we can clone our own stem cells, then if we will use them, we will not be subjected to rejection. Now, there is a fundamental difference, both from an ethical and a practical point of view, between reproductive cloning, which is cloning a full human being, or the intention is to get to a full cloned human being, and a therapeutic cloning, where we stop at the stage of the blastocyst. The process of cloning, the initial process is the same, but we stop at the blastocyst, we destroy the blastocyst, we take out the stem cells, we have now our own genetically cloned blastocyst, but no new human being will become out of this cloning process. So there is a fundamental ethical difference between the two processes. Why is it so important to talk about it? So it is important for many fields in medicine, but I think neurology, and that's why we are talking in this conference, in this seminar, will probably be the leading candidate to derive benefit from stem cell research. As we all know, in the last century or so, society, human beings were able to increase the survival rate almost tripled. The average survival rate 200 years ago was around 30 years, and now we are approaching to around 80 years. Women a little more than men, like always, but that is around the numbers that we are talking about, so we almost tripled the survival rate of human beings. But that comes with a very heavy price, because the older we get, the more degenerative diseases we encounter, and old age is not always a pleasure, and some people say we don't really want this continuation of life because of all these degenerative diseases. Now, a degenerative disease is defined in many ways, but one important way is that the tissue that degenerates cannot be replaced. So that if a brain tissue is destroyed, either by a disease process or by trauma or by a stroke or whatever event, this area that was destroyed will never come back to function. So that's how we get Parkinson's disease and Alzheimer's disease and spinal cord injuries and strokes and so on. So the neurodegenerative diseases are such that we lose function because there is no regeneration of the destroyed tissue. So now imagine that we take a stem cell and we tell it to become a dopamine-producing cell. And we implant it into the Parkinson patient, and he gets up and starts to walk and talk and do everything as someone who doesn't have the disease, because we replaced this particular tissue that degenerated and in normal condition cannot regenerate. If we get a diabetic who is very ill and has a lot of complications, and we take a cell and we tell him, you become an insulin-producing cell, and we implant it in his pancreas, then he becomes a normal person without insulin, without external insulin, and he recovers from his disease. So in this way, we can really cure degenerative diseases rather than treat the symptoms as we are doing currently. So that is a major change in the way we might treat degenerative diseases. We tend to speak about degenerative diseases in elderly people, but that is not true. I am a pediatric neurologist. I treat a lot of children who have neurodegenerative diseases. They suffer terribly. They have a long way to go, and treating them is not less important than treating the elderly and giving them a survival spectrum much longer and better. So it is really covering the whole population. Now imagine the following. Someone who has an end-stage renal disease or cardiac disease or liver disease, and the only way for him to survive is to get an organ transplant. But we are very short, in Israel certainly, but in most countries, there is a shortage of organ donors compared to recipients who need the organs. Now, if we can use the stem cells for one further step and tell it not only to become a tissue type that produces a certain chemical, but to become an organ. We tell it not only to become an insulin-producing cell, but to become a heart, to become a liver. And imagine that we are cloning from our own stem cells our own heart, liver, kidney, lung. We store it somewhere, and we are ready for whenever something happens. We have our own organ to replace, and we are independent on whether there is or isn't someone who wants to donate. So that really is, it might be imaginative, but in science, if you don't imagine, you never get to anything, and it seems like it could be done. So if it's so good, so why am I here? Why do we talk? Well, let's do it. Problem is that it involves, as you can see, ethical, legal, religious, and other issues, and therefore it is something to be discussed. The major philosophical question is, when does life begin? You know the Jewish joke, life begins when the children get married and the dog dies. That's when life begins, but in a scientific way, we don't have an answer. We don't know when life begins scientifically, because we don't know what life is from a scientific point of view. So therefore, it is not a scientific question, but it is a philosophical, religious, social, cultural question, and that's where all the trouble comes from. Why is it important? Because we are using something which could be defined as the beginning of life, or could be defined as a non-life entity. And it would depend how we define it to the degree we can use it. Now, we can take different developmental stages of the embryo and the born person, and to say life begins at this stage or at that stage, and you may be right more or less than anyone else, and no one can prove who is really right. It is a matter of accepting a definition from an emotional, philosophical, religious point of view. Oops. Now, ethicists have a major debate on how to relate to stem cells. If the source of a stem cell comes from an adult or from a miscarried fetus who was miscarried because nature caused it to miscarry, no one really did something in order for the fetus to die, to be aborted, then from an ethical point of view, there is no problem. We can use the tooth that fell out and take out the stem cells from wherever it sits and use it. Maybe we need an informed consent. That can be debatable if it's my tissue or not my tissue, but other than that, there are no real ethical questions. Using aborted fetuses causes the ethical dilemma and the religious dilemma on the abortion issue. I won't go into it. It's a complicated matter by itself. The most frequently used stem cell source is IVF-derived pre-embryo. And the question is this stage, the blastocyst, derived from an IVF clinic, remember, 5 days or 4 days after a sperm entered an egg, is it a living creature at this stage, and therefore destroying it in order to obtain the stem cells is murder? Is it something that is not a living creature by definition, but at least has a potential to become a living person, and therefore it is a questionable murder? And if not, do we take away the human dignity by using something which a human being started that way and destroying it? So these are some of the ethical concerns. Scientific societies have less problems with these questions, and as far as I know, all serious scientific societies have endorsed the stem cell research because from a scientific point of view, it is very beneficial, without any risks, without any damages, from a scientific point of view, and hence why not do it? So here is a partial list of major scientific societies who published their opinion, and all were in favor. Now, we were talking earlier about the media and the legislation. This is a very heated issue around the globe, and different countries have enacted different laws. Some made it as major laws, some as less major laws. Some didn't decide yet on whether to enact it as a law, but almost every country has a debate from the legal legislative point of view. So there are some countries who prohibit any use of pre-embryos, taking the ethical and perhaps the religious point of view from their point of view that this is murder, and therefore you can't kill one human being even in order to save 1 million people if this research will be effective. So you can see here a number of countries. It's not totally updated. Maybe some of the countries have changed their minds one way or the other, but when it was taken from the UNESCO briefings, that was the list. The United States went through an interesting process. President Bush, the former president, at August 9, 2001, at 21:00, pronounced the following: any cell line of stem cells that exists now, August 9, 2001, at 21:00, anywhere in the world, will get federal funding. Any new line after this date will not get federal funding. The idea was that, according to President Bush, that is wrong to destroy a blastocyst from his religious understanding, and therefore he can't support by federal money something which he thinks is ethically wrong to do, and therefore he won't fund it. Whatever was done earlier, if it's already there, he understands the importance of the research. This he is willing to fund. Most American legislators were opposed to this position. The Congress did allocate funds, and President Bush went so far that he vetoed the Congress decision. And up to the end of his ruling, there was no federal funding for that. When President Obama took over the office, I think the first decision that he took was to go away from Bush's position, and he granted federal funding for the research. So now it is allowed and funded in the United States. Germany, again, it might have changed recently, but as far as I know, it didn't. Germany went one step further than the United States, not only not funding it, but actually outlawing it, making it a criminal offense to use German stem cells by German scientists. However, they did not outlaw imported stem cells who comes from outside of Germany. So if you want to be a little cynical, you can kill anyone else out of Germany, but you can't kill a German blastocyst. That's how it reads. So anyway, but the principle in Germany is that it is a forbidden act, not only not funded, but actually criminal. Most countries, however, and as you can see, Israel is one of them, allows by law using IVF fertilized ova in excess, and I'll explain it in a minute, for the purpose of stem cell research. Some of the countries who allow stem cell research allow it only from fertilized IVF-derived stem cells, but they forbid using therapeutic cloning for this purpose, whereas other countries have allowed, and again Israel is one of them, have allowed even cloning for the purpose of therapeutic purposes, stem cells for the research purpose. Now, the religions, the different religions have different approaches. The Catholics, as you may know, absolutely prohibit the use of stem cell research, the use of blastocysts for stem cell research, because from a Catholic point of view, ensoulment occurs at the moment of conception, and the first minute that an egg and a sperm have united, that is a human being. And since it's 5 days later, it is certainly a human being, and destroying it is equivalent to killing, and the beginning of life, from a Catholic point of view, is very different than what science can do today. And this is one of the issues where the Catholics are fighting very strongly against using blastocysts the way we are using them, meaning destroying them, in order to derive stem cells for research. The Protestants, depends on who you talk to. Some allow it, some don't allow it. There are different schools of thought. And the Islam allows it because according to the Islam, a human being starts 3 months after conception, so we are far away from this deadline, and therefore they don't see any problem. From a Jewish point of view, it is permissible. And it is permissible for various Jewish reasons, Jewish legal reasons, which I won't enter into the debate, but bottom line is that it is permissible. Now, you would have thought that there might be theological questions using stem cells for such an advanced change in nature. We are taking a stem cell, we are ordering it to become something which by nature probably would not have happened. We are using it in a way that up to now no one even dreamt that can be used. In other words, are we playing God? Or are we interfering with nature in a theological sense which should be forbidden? The answer for both of them is no. In other words, it is acceptable. Now, I don't want to go into all the theological debates on what is playing God. I think it's a journalistic phrase. It has no meaning from a real theological point of view. No human being can play God by definition, because we are not God. If we would know what God can do, we would be gods. But we are not, or at least we think we are not. So anyway, there are major differences between what we assume God can do and what we as human beings are doing. And it is important to realize that in fact, understanding better nature and understanding what stem cells can do gets us closer from a theological point of view to be believers. Because we now realize how much we don't know how this world is operating. And this world that is operating for so many years the same way that we only discover now has been done by someone who made the rules. It can't be that it just happened by chance like non-religious people think or believe. It's another belief, I think. It's not a science, but it's another belief. So from our point of view, it strengthens our belief, and therefore we certainly are not playing God. Important is to realize that scientific discoveries are revealing existing, not creating new. In other words, the fact that we take a stem cell and we change it and we play with it and we use it, we didn't create anything new. We just took something existing and we used it for different purposes. In fact, this nice building that we are in was not created by God in the 6 days of creation. Someone has changed nature here. And yet no one questions it. Is it theologically wrong? Why don't we sit outside in the sun, boiling, and listening to a boring lecture? That is something that we don't even think about. Why? Because what we are doing, we're taking wood and stone that exists in nature and we shape it in a different way. That is not playing God. More importantly is, are we interfering with nature in a way that we shouldn't? And indeed, if we would create an atom bomb and destroy the world by it, that would be wrong from a theological point of view, because we are abusing nature. But using nature in order to improve the way we live, the way we act, the way we feel, is certainly not only permissible from a Jewish point of view, but perhaps even required. And again, I won't go into the details of how we prove that that is a permissible or even a required way to interfere with nature. God created the human being with an intellect, and this intellect is supposed to work. If we are not using our intellect to improve what we are doing, then why did God give us this intellect? So that is not interfering in a negative way. Now, I think the most important aspect to understand the Jewish position on stem cell research is to define the blastocyst. What is the blastocyst from a Jewish point of view? And the blastocyst from a Jewish point of view is not an embryo. We don't have a name for it because we didn't know about it years ago. I think we should call it a pre-embryo or some other different way. And I think semantics are important in understanding positions. And the reason that the blastocyst is not considered a human being yet is for two reasons. One, that human beings become, from a Jewish point of view, an entity only after 40 days of gestation, for reasons that I don't have time to go into, but certainly not at the age of 5 days. But more importantly, it has a potential to become a human being only if it is in utero. If it is outside the uterus, it doesn't have a potential to become a human being unless someone is doing an added act. By itself, if it will sit there in the freezer or outside, it will never become a human being. It will become a human being only if someone will take it and implant it in a woman. Only then will it become a human being. And if it is in excess, and in excess means that no one wants this fertilized egg anymore, then this fertilized egg will never be a human being. And hence it doesn't have even the potential to become a human being, only a theoretical potential, but not an actual potential. It can never be defined as a human being at that stage. Now, what does it mean that it is in excess? Take a couple who goes to an IVF clinic and they get the procedure because they want a child and in natural ways they can't have it. So the woman is stimulated to produce, let's say, 15 or 20 eggs. And all are collected and all are fertilized. So we have now, for this couple, 20 fertilized eggs. Obviously, we don't reimplant all the 20 at once. No one will survive. So what we do is we take 1, 2, or 3, and we introduce it to the woman. Let's say we took 3, and let's say all 3 took. And this woman delivered triplets. This woman probably will say, I have enough with my job. I have now a lifelong job to take care of the triplets. I don't want any more children. But we have 17 fertilized eggs still in the freezer. No one claims them. This couple doesn't want it. It doesn't belong to any other couple. So what is the fate of these 17 fertilized eggs? Now multiply this 17 into how many IVFs are performed, and you'll get to enormous numbers. In Israel at the moment, as far as I know, there are over 30,000 fertilized eggs, more than 5 years, that no one claims them. In the United States, there are over 1 million such fertilized eggs. So these are fertilized eggs in excess that no one claims them. So what do we do with them? One option is to keep them in the freezer until someone will come and redeem them, whoever it will be. The other option is to throw them away. It's a waste. It costs money to keep them, and no one will make any use of them. So throw them away. Instead of throwing them away, if we can use them for research that will save millions of lives, why not do it? So since by definition, and that's a Jewish definition, these fertilized eggs have no human being status, therefore, the best to do with them is to use them for research. That is the logic that allows this situation. Okay, I guess my time is up. I could have spoken about some other aspects of the issue, but this is the summary. A pre-implanted fertilized egg, and again I stress it's a pre-implanted and it's not an embryo yet. We should respect it as a human part and potential life, but it has no human status. Therefore, research on stem cell via destruction of a blastocyst from a Jewish point of view is permissible. Thank you.
Thank you very much for this certainly not boring, please stay a moment, not boring lecture. You have raised several issues that are controversially discussed, as you said, in several countries and in different religions, and I'm sure there are a few questions here. Please. Yeah, Leon?
Leon from Carol University of Medicine of Bucharest. I am a physiologist and neuroscientist. My question for you is, do you think it is possible to know beginning of the life before to know what is the life itself?
Right. No, I'm saying you can't define the beginning of life if you can't define life. And from a scientific point of view, we don't know what life is. Every cell has a life in it in a scientific way, but certainly not from a cultural way. If you take a culture of a few cells, they are not a living person, and no one would claim that you're not allowed to destroy it, right? But from a scientific point of view, they are as live as I am alive, right? So that is really meaningless to define life or when life begins from a scientific point of view.
You didn't mention another option, and this is donate those eggs to women who need it, who want.
You mean the one in excess?
Yeah, yeah.
Well, that is a very complicated matter because that actually is a form of adoption. It is not a real genetic child. I mean, if a couple, A and B, have a fertilized egg and they give it to a couple, C and D, this couple is just a surrogate couple for the fertilized eggs. So the question is, are we encouraging such surrogacy? Is still very problematic. I don't know that any country yet has decided that that should be permissible. I don't know. But even if we would use it, there will still be enough in excess for both giving some couples those types of eggs and still remain a lot of excess eggs for research.
Well, there is a lot of debate, public debate going on in the ministry, what to do with the excess eggs. In the meantime, they're in the freezer.
Well, in England, as far as I know, after 5 years that there are no claims for it, they destroy it. Well,
yeah, I think it is still a very controversial topic, and it is solved differently in different countries, as we heard. Since we are running out of time a little, I would like to thank you again for this fascinating talk.